All right, does anybody have any questions on how I found g of x, or then how I found the derivative of, or yeah, they're all g of x, then the derivative of g of x?
Can you do number 4?
Yes. All right, so number 4 is t to the 1/2, okay? So the antiderivative of t to the 1/2 is t. We're going to add 1 to this. So 1/2 plus 2/2 is 3/2. And then we're going to divide by 3/2, which means multiply by 2/3. And we're going to evaluate that from 4 to x, okay? That means we're going to plug an x in and then minus plug a 4 in. That's the fundamental theorem of calculus part 1. So it's going to be 2/3 x to the 3/2 minus 2/3 times 4 to the 3/2. This term on the left, we don't do anything with because it's an x. And over here, 4 to the 3/2 means the square root of 4 cubed. The square root of 4 is 2. 2 cubed is 8. And 8 times 2/3 is 16/3. Okay, so that's how we get the 2/3 x to the 3/2 minus 16/3. And then to take the derivative of that, 3/2 times 2/3 is 1. X to the subtract 1 from this, and 3/2 minus 2/2 is 1/2. The derivative of a constant is 0. So that's how I get my derivative. Okay, hopefully everyone found and got f of x down here. If you realize that uh, every one of these answers over here, okay, is just, instead of writing this function, it's putting an x in there, okay? So we have sine x, we have 3x squared, and we have x to the 1/2, okay? And that's really leading to today and what the fundamental theorem of calculus part 2 is all about. Okay. So, like I said just there, is that what you want to take out of this is whenever we have a constant right here, and then we have a function, in this case, our function is x every time, to find the derivative of g, you're just plugging in x into this, okay? And all this work that you did on every one of these proves that that works, okay, by doing the fundamental theorem of calculus part 1. Now, when you flip it over to the other side, you should start realizing, because the x is on the bottom, I'm getting the negative of that function. Okay, and just like we did before when we flipped the numbers and the smaller number was on the bottom, or excuse me, the smaller number was on the top and the larger number was on the bottom, we negated the function. It's kind of like this. Obviously, we don't know if x is smaller or bigger than that, but x is just a function now. It's not just one number. All right, so does anybody have any questions on how I got g of x, and then flip side of that, how I got g prime of x?
Could you do 7, please?
Uh-huh. All right, so number 7 is find the antiderivative of t plus 2. So the antiderivative of t is 1/2 t squared. The antiderivative of 2 is 2t, and we're going to evaluate that from x to 2. Okay, we're just doing the fundamental theorem of calculus here. So we're going to do it just like we've always done it. We're going to plug a 2 in. So it's going to be 1/2 times 2 squared plus 2 times 2. That's f of b minus f of a, which is plug an x in. So it's minus and then 1/2 x squared plus 2 times x. Okay, right here we get 2 squared is 4 and half of 4 is 2. Here we get plus 4. Here we get minus 1/2 x squared. And here we get minus 2x. And then just by combining like terms, that's going to give you 6. And then I just rewrote it with the 6 at the end and the x squared in the front. So I got negative 1/2 x squared minus 2x plus 6. The derivative of this is 2 times negative 1/2 is negative 1. Okay. X to the subtract 1. 2 minus 1 is 1. Okay. The derivative of negative 2x is negative 2. And the derivative of 6 is 0. There's my derivative. Okay. And if you just go back and you look at this, since the x is on the bottom, I negate this function. So I'm negating negative, plug in x in, x plus 2. And when you negate x plus 2, you get negative x minus 2. Okay. At the bottom, you should have gotten negative f of x. Okay. So if you have a constant on the top and your x on the bottom, you're going to negate your function, compared to when we were on the front, we just plugged the x into the function. Okay. The whole point of this is you realize that what we're doing is, when we're getting to this section over here, the derivative part, we're taking the derivative of an antiderivative. Okay. And it's kind of like taking the square root of something squared, right? When you take the square root of 5 squared, you just get 5. They kind of cancel each other out. Well, when you're taking the derivative, this is g of x, right? So if I'm taking the derivative of this function, that means take the derivative of the antiderivative. And the derivative of an antiderivative is just this, except we're plugging the x in now instead of just saying t to the 1/3. And then since x is on the bottom, in this case, negated. Any other questions on last night? It's really not about the work as much as it is about understanding what I just said there about the fundamental theorem of calculus part 2 when you have a function in there, because we're going to change this today from this being an x to this being like a more intricate function, like say x squared, 5x squared, 2x plus 3, stuff like that. Okay. Questions? All right. Let's look at the notes for today, which is assignment number 12. We're still on the fundamental theorem of calculus part 2. And basically what I was just telling you is what this is saying right here. Okay. If f is continuous on an open interval containing a, that's this point right here, this value a, then for every x in the interval, the derivative of the antiderivative of f of t dt is equal to f of x. Excuse me.
Does the derivative sign and integral sign basically like cancel each other out?
That is correct. Okay.
So what's really the point of it then, if it just cancels?
Well, but you have to still plug in this x. Okay. And today you're going to see that x down here is not going to be an x anymore. Here it's an x squared. Here it's an x cubed and an x squared. Here it's a sine x. Here it's a 3x squared. Okay. So now things are going to start changing when we're integrating from, a number to a function. Okay.
Okay.
All right. So this first part right here is just taking what you learned yesterday and putting it into play without actually taking. Okay. So yesterday, what we were doing is the first half of the question was take the antiderivative of this. And then the second part was saying take the derivative of the antiderivative. Okay. And now we're just going to do the fundamental theorem of calculus part 2, which simply says this is my a value. Okay. So if I'm integrating from a to x, f of t dt, then this is g of x, right? G of x is this antiderivative. Then g prime of x equals, just plug an x into that t, and I get f of x. Okay. And that's really what the last question was, after you did 1 through 4 and you answered a question, and then 5 through 8 and you answered. That's what you're doing. Okay, so now today, instead of doing the fundamental theorem of calculus part 1, which says take this antiderivative and then do f of b minus f of a, we already know we can skip that now. We do not need to do the fundamental theorem of calculus part 1. We can simply jump right to y prime is equal to, plug your x in, so x to the third minus x, and that whole thing is raised to the 5th power. Like I said, if I take the antiderivative of this function, which, by the way, do we know how to take the antiderivative when we're raising something to the 5th power? We do not. Okay, we would have to FOIL this whole thing out. It's not really called FOIL, but we would have to multiply this whole thing out, which would be some big long polynomial, take that antiderivative, and then plug in x minus plug in 0. And that would be a whole lot of work. Now we know that the fundamental theorem of calculus part 2 says just plug an x in for all your t's. Okay, so we get to number 3. And it's just saying the derivative of the antiderivative. Okay, instead of saying find g prime, we're just saying take the derivative of the antiderivative, which means plug an x in, we get the square root of 1 plus e to the 5x. Okay, number 4, g prime of x is equal to, we're just going to plug our x in, 5x to the 4th minus 4x plus 1. Okay, here's one where I can take the antiderivative off the top of my head, right? The antiderivative of this function would be 5t to the 4th divided by 4 minus 4t squared divided by 2 plus 1t, okay? And if I go ahead and plug in, and yes,
It's
off the paper.
5x to the third.
No, I'm taking the antiderivative, right? So when I take the antiderivative, I add 1 and divide by the new exponent, right?
Okay.
Okay. I'm doing it I'm doing it the way we learned prior to today. Okay. So I'm going to take the antiderivative, and now I'm going to do the fundamental theorem of calculus part 1, plug in x minus plug in 0. And if I plug in x into this whole thing, minus I plug 0 into this whole thing, I'm going to end up with 5x to the 4th minus 4x plus 1. Okay. But now that we know the fundamental theorem of calculus part 2, we don't need to do all that algebra there. We could jump right to it. All right, so take a look at number 5. We're switched here. X is on the bottom now, okay? So we're integrating the opposite direction. So now my answer is going to be negative. So we're going to do negative and then tangent x. All right, and then the last one, before we get into some chain rule stuff here, is since my x is on the bottom, I'm going to negate and then plug in an x into my p's. So this is going to be 2x to the 4th plus x plus 1.
Wait, Mr. Masson,
Uh-huh.
on number 4, why would it be like in the g prime of x, it's 5x?
Oh, you meant this one, didn't you? Not
Yeah.
this one. I'm sorry. You are correct. I wrote the wrong one there. I
Thank
thought you meant
you.
up here. Thank you
Thank
for
you.
correcting that. Good call on that. Okay. Oh, so are there any questions about the fundamental theorem of calculus part 2 when it's just an x here? X on top or x on the bottom? Okay. It's not going to get harder, okay, because you already know how to take derivatives, okay? You just got to think a little bit more. All right, so the fundamental theorem of calculus part 2, now when this is not an a, which is a constant, and an x up here, and now instead I have a function down here or a function up here, or both, okay? I could still have an a, which I do in number 7 and in number 8, okay? I still have an a value and a function up top, or that could flip, or I have 2 functions like I do in number 9, and then in number 10 we just flipped it. Okay. And basically it's a chain rule. Okay. So what this is saying is I am taking f of, remember, this is going to be like your f of x right here, okay? F is a continuous function, so f of x is equal to this, okay? So we're going to do f of g of x, which means the top function times the derivative of g of x. That's the chain rule right there. Minus, if this is a function, f of h of x times h prime of x. Okay, so first one here, number 7, we have a constant down here. Okay, so to find g prime of x, we are going to plug this in. So it's f of g of x. So it's f of, and then g of x is x squared. This is my f, and I'm plugging this g of x into that right there. Okay, that would be f of g of x, right? You're just taking the g of x function and plugging it into the variable of the f function. So it's going to be 5, that's f of g of x, x squared. Chain rule, derivative of g of x, or this function that is up on the top, and the derivative of x squared is 2x. And now I just combine like terms. 5 times 2 is 10, x squared times x is x cubed. Okay, again, one more time. We could take the antiderivative of 5t, and that would be 5 halves t squared. And then we plug in x squared into 5 halves t squared, and we plug in 3 into 5 halves t squared, and we subtract them, and we get 10x cubed. But instead of having to do all that work, now we have the fundamental theorem of calculus part 2, which is kind of like a shortcut to getting there. All right, so over here on this one, okay, we're going to plug, excuse me, plug sine x into t. So we're going to get the square root of 1 plus sine squared x. That's all under my radical. Chain rule, the derivative of sine, and the derivative of sine is cosine x. And it probably is more typical to write that cosine out front and say cosine x times the square root of 1 plus sine squared x, just because we don't want to accidentally draw that radical over this whole thing. But it's not wrong if you wrote it in that form. Okay, so all we did now was add this twist of, if this is not an x, right? And when it was an x, we really were taking the derivative, right? We plug in our x into this function, and then we take the derivative of this g of x up here, and the derivative of x is just 1, right? So we don't write that. We don't talk about that. But down here, we're just doing that. Okay, so now we're going to put in this two functions, an f of, or excuse me, a g of x and an h of x, and that's just doing this right here, okay? So what we're doing is we're starting on the top, and we're going to plug in an x cubed into that t. So we're going to get cosine 2 times x cubed. Chain rule, the derivative of x cubed is 3x squared. Okay, so that's your f of g of x times g prime of x minus, now we're going to do f of h of x. So we're going to plug h of x into here and get the cosine of 2 times x squared. Chain rule, the derivative of x squared is 2x. Okay, now I can't combine these. These are not like terms, okay? Some people may decide that they like to put this 3x squared and this 2x in front and write it as 3x squared cosine 2x cubed minus 2x cosine 2x squared. Okay, but this is not wrong if you left it like that. If it's multiple choice, it might be like this. All right, number 10, okay? Good news is always when we have a constant in there, okay? Because then we only have to do the one part of this, okay? If there's two functions, you got to do two parts. Okay, but you have to notice that we're switched here and our function is on the bottom and our constant is on the top. And when that happens, we have to negate. Okay, so we're going to negate, and now we're going to just do everything normal. Okay, we're going to plug 3x squared into this u. So we're going to get the natural log of 2 plus, and then parentheses, 3x squared squared. Okay, we're squaring the u, and this is my u. Chain rule, the derivative of 3x squared is 6x. And once again, multiple choice, we're going to clean this up a little bit. We're going to move the 6x into the front and get negative 6x. And then natural log of 2 plus, and then this most likely will be multiplied out. So 3 squared is 9, and x squared is x to the 4th. Okay, so now we're just taking some stuff we got from first semester, right, and putting in back in a chain rule that we have to make sure that we're doing the derivative of our function out here, as well as substituting into here to find that derivative. Okay, like I said, again, I just want to keep repeating this, is we could always do this the long way, right? But the problem is we don't know how to take the antiderivative of cosine 2t. We could take the antiderivative of cosine t, but not cosine 2t, okay? We don't, as a matter of fact, the only one down here that we know how to take the antiderivative of is 5t. Okay, we do not know how to do the antiderivative of any of these other functions. Okay, I guess we could change this to be, no, that wouldn't really work either. 1 plus t squared to the 1/2, but we still wouldn't be able to do that. All right, go ahead.
Oh, sorry. On 7 and 8, why didn't we do the minus part?
Because when you have a constant down here, you don't plug it in because that's not a function right there. Okay, so
Okay.
that's just like what goes back to what we were doing yesterday. What ends up happening, I don't have, where did I put yesterday's? Right over here. Okay, so what ended up happening, okay, when you had that constant out there is when you took, because what ends up happening is when you do when you plug in that constant, okay, we're then taking the derivative of that, and when you take the derivative of constant, it's 0. Okay, because what we're doing is we're doing a shortcut, right? So you can't really say that it would be minus this constant out here. Okay, what you have to do is when you're doing it when you're plugging in the constant, you're doing it the method of taking the antiderivative first and then finding the derivative of the antiderivative. We're just jumping right to the derivative here. So we're not plugging this in because all of this last night showed we don't have to plug it in because remember, this is g of x, right? This is not g prime of x. So when we found g of x, we did plug it in, but this became a constant. We took the antiderivative of that constant and it went away because we took the derivative of this constant, which became 0. We're skipping take the antiderivative of this first and then take the derivative of that to get the derivative by just doing the fundamental theorem of calculus part 2. Did that confuse you more or make it more clear? I'll go with made it more clear. All right, do I have any other questions? Mazen, I'm not sure if you were trying to talk there. Your box lit up yellow, but
Yeah,
you were muted.
It,
Okay.
it did help. My mom just talked to me, so I
Oh,
was
okay.
paying attention for a second.
Okay. Yeah, no, you're good.
But I, like, before she started talking to me, I get what you mean.
Okay, good. All right. Anybody else have a question on this? All right, guys, that's all the notes for today. So you can go ahead and just get started on that homework, and I will see you tomorrow.
Have a good day.
You too, Katya.